Raining in Greenland. Yes, I heard that it rained. Was it tall? It's the most inaccessible part of the glacier or the ice cap that's on Greenland. Is that right?
This is the first time in history. I repeat, in history, not in the 10 last years or whatever in recorded. The first time in history that this has happened, and they know that because they analyzed the snow samples, the ice samples, so they can go back hundreds of thousands of years, and there has not been a case of rain in this area. And the significance of it is very disturbing. There's a gentleman by the name of Ted Scambos, who's a senior research scientist at the University of Colorado at Boulder's Cooperative Institute for Research in Environmental Sciences, that said that this has been significantly worse than they have anticipated till now. This is a record. The rain itself is, of course, melting snow, but worse than that is the implication of the fact that it's a clear sign of the environment heating up. This is the third time that this has happened in recorded history, that they reached a temperature above melting. And the first time that it rained, it actually melted it melted a huge amount. I will get into that, but let's look at this video here.
Over the past week, Greenland's highest point saw rain instead of snow for the first time on record. Hours of rain poured down at the ice sheet's 3,200-meter summit as scientists with the U.S. National Snow and Ice Data Center witnessed temperatures above freezing for 9 hours. Senior scientist Walt Myers says it's a rare sight.
We have atmospheric data, that kind of we can infer conditions, and that indicates no rain. That there hasn't been any rain since those records began in 1950. So in our records, it's a unique situation.
7 billion tons of rain fell across Greenland within a 3-day period the past week. It's also the largest amount on record. Higher temperatures have also triggered the warming of ice sheets, which experts say are melting faster. Ice loss on August 15th, triggered by rain and high temperatures, was 7 times the average for mid-August.
You raise temperatures a couple degrees in the mid-latitudes, it's something you don't maybe notice even, but raising it from 1 degree below freezing to 1 degree above freezing is the difference. If you're in the Arctic Ocean, it's the difference between ice skating and swimming.
The record-breaking rain is the latest in a string of warnings on how climate change is affecting Greenland's ice sheet. A massive ice melt in July saw enough water released to cover an area the size of Florida in 2 inches of water. The latest UN report on climate change said the Arctic region is expected to warm at least twice as fast as the global average, and that it is unequivocal that human activity has caused global warming.
Yeah. So very disturbing, and we don't know. We've covered this issue in the past, whether we're reaching the tipping point. We don't really know, but what is clear is that scientists have not
there's
expected.
More than one tipping point. There are many tipping points, and one thing that the sky is falling crowd does is they get overly concerned about one tipping point or another. When you really get into it, the world actually is a very big place, and no change happens really suddenly. Now, having said that, I am aware of the methane bomb, which could conceivably cause a lot of grief very quickly. But even there, it's not a simple thing. The Earth is round, and the closer you get to the pole, the colder it is. And so, is all the mind says, oh, the methane bomb, all this methane is going to come out of the ground. Well, at once, over a period of a year, or what? The Earth is curved. Obviously, the southern parts are more in peril than the northern parts. And so they would, I would expect, that would be a good thing to do to determine the lowest point in the Earth in the northern hemisphere where permafrost goes, and just really watch, these fringe areas and see what they're doing, and not ignore the other areas, of course. But I'm suggesting that, watching those areas and getting a good handle on what's really going on would be a really good idea. Having said that, I do not minimize anything at all by saying the world's a big place. The fact is, we're looking at 2 degrees of warming, and in the American mind, that sadly means very little, because they don't know what Celsius degrees are. All our news is still in Fahrenheit, and this is not a small issue. Yeah. 1.8 degrees centigrade Fahrenheit is 1 degree centigrade. So when you're talking about 2 degrees warming, what are we talking about? 3.8 degrees, actually. And when you think about it, 2 degrees, you can't even tell the difference in a room. You walk in a room, but 3-4 degrees, actually, you can feel that. And then there's the fact that, it's not equally spread. If we're equally spread, that might be easier too. But the northern hemisphere, the further north you get, the more it's changing. So, you've got multiple effects of varying degrees on a very big world, multiple tipping points, a very, very, very complicated issue. And so complicated that it continues to be ignored, sadly.
Yeah, my greatest fear is that scientists will say one day, well, unfortunately, we thought we had more time, but we actually already reached the tipping point in May or whatever that may be, and we can't do anything about it anymore.
That's a danger of looking at a hard tipping point there, because the truth is, in some ways, we have crossed areas, tipping areas, and some of the consequences are not going to be avoided. But that's a problem where people think it's all one way or the other. It's all a binary thing, when there actually there are infinite shades of gray in between.
Well, yeah.
So
Yeah, Keith, but there is a cumulative effect of all of that. When you sum everything up, you either are in a positive feedback loop or you're not. So yes, there's many different processes that are happening, but overall, you are going to reach a point in which all the sum of all of these processes is either going to be preventable, like retractable, or it's not.
Well, feedback loops, we are in positive feedback loops. There's no doubt about that. But whether or not they are runaway is a different issue.
And last week you brought it, actually, the news about Siberia, that there was a huge release of methane recorded recently.
The point I was making there, I wanted to bring out, was that carbon-14 dating has been used to determine how old fossils are for a very long time. And one of the things that's going on is all the sequestered methane, all the sequestered carbon in the Arctic is very old, and it has a low isotope carbon-14 count. So the scientists are monitoring the amount of carbon-14 in the relative quantity, the ratio in the air, and it very clearly shows that if they analyze the methane, they can kind of tell where it comes from, and it's fossil methane that's coming. That's a point I wanted to make, that this stuff is actually being tracked now, and it's actually happening. Because, and my point there was, the methane issue has been ignored by conventional environmental people for decades, and it's only now being recognized as a serious thing. It's been recognized as a potentially cataclysmic thing, whatever, for forever by the fringe community, who have seen it. Oh, we're going to we're going to become Venus in 5 years, and so on. A lot of strange claims have been made, but it actually makes a point about the positive feedback issue, because from the best I've been able to work out, the methane issue will by itself cause about 1.5 degrees of warming. Whether that's true or not, I'm not going to advocate that position. That's my knowledge from what I've been gathering, what I go by so far, reading a lot of things. And so what it does, it's positive that it aggravates the effect, right? So that if you pump some CO2 out your tailpipe, that's going to cause a little bit of warming. That's going to in turn release a little bit of methane, which will cause a little bit more warming, which causes a little bit more methane release. But does that infinite series go to zero or not? And that's the issue, because if it doesn't, then things just get warmer and warmer and warmer and warmer, and things run away. But now, from a physical point of view, we will not become Venus. The Earth could become uninhabitable for humans, but it's unlikely that the feedback loops could go that far. The important thing for us, though, is that we are doing things so that the amount of feedback we will generate will be enough to put the world into a state where we cannot survive on it. And right. That's the issue.
Definitely not survive, not have a world that we recognize in its current form. The U.S. Pacific Oceanic and Atmospheric Administration has issued a report that stated that July was the hottest month average temperature so far. If you look at the stats, this is how it looks. It's dire. It's getting there. We're not curbing it, and it's a huge concern. So especially when you're a community in Greenland and you're seeing things around you that you don't recognize and they look odd. And this is what this next video is. It's showing how Greenlandians are like stunned by what's going on around them, and they're shooting it. To us it looks normal because we don't know what their natural surrounding looks like normally, but to them it looks like an aberration. Here it goes.
Phần qua thì trôi không chút.
Yeah. Oh, that's from there. It looks like you can't turn anywhere now without either getting into fires, global warming, and there seems
Well, that's the way it's going to be. You know, the CO2 in the air is not going down; it's only going up. Currently, this month, this month means last month. The CO2 in the air is 416.96 parts per million, which is an increase of 0.56%, over 0.5% over last year. That's how much it goes up. And, you know, it doesn't not go down. And the idea that we're going to do anything to bring it down, like through any mechanical means, is a pipe dream, you know, for a lot of reasons.